right, good morning. As you can notice, I have a little bit in here at the beginning. Don't worry about scribbling everything down. I'm going to be talking about it here as we get started. But today we're going to chat a little bit about quadratic models. Now, what's that mean? It basically means it's story problems. They're going to have parabolas, most of the time opening downward as their shape. So we're going to chat mainly about objects that get launched or tossed or thrown on Earth. That's where most of our stuff gets done. Can be modeled by this function. Now, this can be intimidating at times. There's 4 different variables we're playing with. But once we kind of understand what the different pieces mean, it helps. And so keep this out as you're doing things to kind of give you some guidance. Okay, so this h at the beginning is our end height. Once I toss my item and it lands somewhere, in my hand, on the ground, whatever, how high is it? Okay, different from h sub o, which is where the object started. Now, you're kind of thinking, well, what do you mean? So like, let's say I'm throwing a baseball, and I'll throw it as far as I can. When I go to throw that ball, wherever it leaves my hand, the height of that would be my h sub o. Where the ball lands, well, if I'm playing catch with somebody, or where they catch it, would be my end height. So where the object starts, where the object ends. Okay? And in between those things, we also have to pay attention to how long is the object in the air, the time, which is typically going to be in seconds, and the initial velocity, the initial speed that that object has. So when it comes out of my hand at 99 miles an hour, yeah, I wish I'd be in a different profession. What speed is it coming out of my hand? All these things come into play. How high off the ground? How long is it going to travel? How fast is it going for us to be able to get some information on this? So a couple more things to make note of. Is this negative 16 going to be here all the time? Yes. Okay. Well, what is that? What does that mean? Okay. The negative 16 is actually in feet per second, and this is the acceleration due to gravity. In other words, gravity itself pulls things down. Otherwise, they'd float around forever. If you've ever seen, people or objects on the moon, they kind of float because the gravity is different. Here, gravity makes things come back down. So that's the coefficient. That's the number, the speed at which gravity sucks things back down to the Earth. Now, if we're not in the United States and we measure in metric, okay, everything's going to be the same in this expression except for the negative 16. And that negative 16 turns into negative 4.9 meters per second because that's the conversion between feet to meters. Okay? So I do have to pay attention to the problem and see if it talks about feet, I need the negative 16. If it talks about meters, I need to use the 4.9. Okay? Otherwise, we're always going to have this available to us. So we're not going to have to worry that we're not going to have it there. Just something to mention. Okay. So let's get down to business here. And I did pay attention to some of you asking with our little survey from last week, with our first Easter egg, that sometimes, Hardy, you need to slow down some. That's true. So I'm going to work on that here. But you can always rewind me if you need to, but I'm going to try and slow my roll a little bit here as we're talking. Okay, a rocket is launched directly upward at 45 feet per second. So we're in American, measurement here. From a platform 70 feet high is given by this equation. Okay, before we get to that, let's take this on. What is this S of t business? Okay, because you're like, well, up here, it was h. Now it's S of t. What's the deal? Okay, it's still going to be that ending height. But we're speaking in a functional, okay? This is function notation. And all that means is whatever number is in the parentheses here. Okay, this t value is our time to see where in the air our object is. It's asking for a snapshot of that particular place in time. So like if this number was 10, I would be figuring out, hey, 10 seconds in, where is this rocket going to be? Or 5 seconds, or 8 seconds. It's just a different way of notification of saying, what will the height be at that time? Okay? Height at that time. That's a good way of, that's a better way of putting it. Height at that time. That's, see, even sometimes I learn something to say a little bit better as we go along here. So, okay. The other thing I would mention if you have things in worksheet form or a form like this is, go ahead and label the things that you know right away. Now, we're going to do it right here with the questions, but even if you weren't asked all these questions, it's good to label the stuff so you know where the pieces are. Okay, so what is the initial velocity of the object? What is the v sub o? What number is in front of t? Okay. 45, not just 45 though, what's the velocity? 45 feet per second. Okay, the labels do make a difference here because they let people know, is it feet, is it inches, is it yards, you know, what is it? What will be the object's maximum height? Now this is a little different. Now we got to get creative. So here's what we're going to do. We're going to pull out our calculator here. I'm going to move me. I don't need to be over there. And what we're going to do is we're going to let the calculator help us on some things, even though we're going to learn there's a few tricks to the trade. Doesn't there always seem to be? We don't have t here, so we're going to use x. So negative 16x squared plus 45x plus 70. Now, a couple of things to make mention of. When we go to graph this, we're going to run into a little bit of an issue. And the issue is, there's a parabola here, but it goes up higher than my screen is, and then comes back down. So how am I going to get it where I can see the whole parabola? Now, this is just my personal opinion. Everybody's going to have their own ways. I like to look at the chart. So I'm going to hide this for a minute. I'm going to do second graph. And I'm going to take a peek to see where the biggest number in the y column is. Okay? 99 seems as high as it goes. The negatives, I don't care to deal with. So 99. So now what would I do? Okay, what we're going to do is we're going to go to Window, and we're going to increase the y maximum bigger than that biggest y value. Since it was 99, I guess I could go to 100, but I'd really like to go a little higher than that. So I don't know. I'm going to go to 120, just something bigger than 99. Okay, I wouldn't go to 1,000 or something like that. So now I pull it up. So here's basically what we're saying. Okay, I'm going to pull the chart for one more thing, just to let you see some of the pieces and how this works. Okay, if I go to 0, the beginning point, notice the number in the y column, 70. Okay, that's my initial height. That's where my object, my rocket, started here on a platform 70 feet high. So here, okay, is where my rocket started. And then it went up, but it came crashing back down to Earth. So what's this maximum height going to be? Well, there's a way of officially finding this out. Unfortunately, I can't just look at the chart and say the biggest number I see is the highest point. That's not necessarily going to be true. So what we're going to do is this. If you are attempting to find the answer just using algebra, okay, one way we can do is we can find the vertex, because we want to find out that point at the very top. So if we do this using algebra, you do have a help sheet in with this section, okay, called Quadratic Apps. If you haven't seen it, you can check it out on the classroom there. So find the x value for the vertex. Okay, so the opposite of b over 2a, you're like b and a. Yeah, Hardy, I don't see those anywhere. Or in the equation up there, where are those at? These are still in standard form. Remember when we did standard form last section? It looked like this. We could find our vertex and stuff. These are in the same order, which means for this problem, my A would be negative 16. It's the number in front of t squared, okay? 45 is going to be my B value. And my C value is going to be 70. Okay? So, opposite of B, opposite of 45, over 2 times A. 2 times negative 16. Now, I'm going to actually get out of my graph here for a second. So 2 times negative 16 is negative 32. So negative 45 divided by negative 32. Ugh. Yuck. 1 point, we'll call it 1.4. Okay? Now, we also have to understand when we're looking at our graphs on this, okay, the x value is going to be our time, okay? So x is time, y is height, which makes sense. How long does it take for it to be at a certain point? Height, it goes like the y-axis does, okay? So this is not my answer. Actually, it's going to be my answer to C. So 1.4 seconds. To find the y value, okay, so again, x value, time, y value, height. I can plug the x value into y equals. I can plug it right back in here. Or I can use trace and type the x value in. Now I'm going to show you both. It's just how I like to roll with things. So if I'm doing this algebraically, what I would do, okay, here's my equation, negative 16, and every place that I saw an x, or a t in this case, I would plug 1.4 in, because that's my height value, okay? So my t, plus 145, 1.4, plus 70. Okay, now notice, I get 101.64. Now I'm not going to write that down yet. Okay, make a mental note. I'm not expecting it to be perfect, but in the ballpark. If I go back to my graph, okay, my other option is to use the trace function right here. Type my x value in. So notice it says x equals 1.4, which is what I got here. And hit enter and watch this. 101.64. Okay, they both work. So depending on how you want this to be, they'll both get you to the right answer. Okay, so not bad. And like I said, we already answered the next one. How many seconds have elapsed? It's just my x value. Okay, so maximum height, again, is y. Okay, y value of your vertex. How many seconds? X value of your vertex. Okay, and so the only thing left on this one that we could possibly want is to know some heights for the exact times. Now again, don't make this difficult. Time is x, height is y. We can do the exact same thing that we just did for that last one. Let's keep this simple. All I have to do, honestly, here is hit trace, hit 1, that's my time. That'll tell me the height. You want to make it even simpler? Well, I won't do that quite yet to you. We're gonna stick this out for a sec. So trace 2, 96. Trace 3, 61. I got to let you in on something now, though. We could have found this even quicker. Now, I can plug this in like we did up above when we did the 101.64 the first time. When we did it here, that would work for all of these. But here's the fast way. If you pull the table on your graph and just follow the numbers, 1 is 99, 2 is 96, 3 is 61. I can pull them right off the chart. So I got lots of options here on how I can find this. Okay. One last piece. Find the average rate of change in height. Average rate of change is a mathematician's very fancy way of saying a one-word concept that you know a lot about. Okay, rate of change basically is slope. So what are we trying to do here? Okay, we're going to take what's called the difference in y over the difference in x. Now, if you're like, what? Let's simplify. Subtract your y's over subtract your x's, just like we do with slope. So when I look at these, okay, and I'm going to change this. We're going to change this to t, change in t. So if I have t, 3 minus 1, okay, because it's the difference. Then I want to take, where was I at 3? 61. Where was I at 1? 99. And I have to keep them in that order. I can't just naturally do bigger minus smaller. It has to be the same order. So here, since I started with the 3, I start with the y that's in that same one. And so what I've learned is negative 19, it's a rate feet per second. And just to let you see, you're like, well, Hardy, what if I did 1 minus 3 here? Would I still get to the right answer? Well, more than likely you would. As I try to grab my help sheet here. But you've just got to remember, if you start with the 1 now this time, you would start with the 99. Okay, as long as we're consistent with the same height and time being in there, it just means the negative would move and I'd still get negative 19. Okay, either way will work. We just got to stay patient with it. So that's when we're launching something. So throw it would be in this, launch. I can't think of any other fancy words for launch or throw here. But there's one other option that comes in. So what happens if we just drop it? What happens if I'm just standing on the roof? Hopefully not. Just drop it. Does that change the initial velocity and things like that? Yeah, it actually does. Because if you think about it, now, instead of me just taking something and going, well, hang on a second here. Now my screen is doing funny stuff. So, excuse me, sorry for all that moving around there for a second. My screen was doing some funky stuff. So now I think we're back in business, hopefully. Okay, so what happens if we just drop the object as opposed to launching it? Okay, let's start going through the pieces like we were up above. So as we start looking up there, we're like, okay, so the ending height, gravity is not going to change no matter where we are. So my initial gravity here, my acceleration is still negative 16t squared. But here's the question. So normally we say our initial velocity, if I haven't thrown it, if I haven't launched it, I just drop it, what would that initial velocity be? I'm not adding anything to it. I'm just letting gravity do its thing. So that would be, my v sub 0 would be 0, okay? So 0t plus, and what's my initial height? 120, okay? So if I'm looking at this whole thing, basically what I'm telling you is, okay, v sub 0 equals 0, and h sub 0 equals 120. That's where I start. That's how fast it was when I dropped it. So if I simplify this, always is helpful when we can simplify stuff. What we're basically trying to tell you is, if you drop it, okay, your initial velocity is always going to be 0. So you can kind of cut that middle piece out. Now I could type either of these into the calculator or use them and be just fine, but just something to consider. So when I go back and start doing this, negative 16x squared, again, because I don't have a t button that works functionally with this. Now again, remember, this whole situation starts at the y-axis, okay, when x equals 0. Like, this would be like if I was a mind reader and it was before time. That's not what I'm doing. So this is really the only piece I need to be paying attention to. So basically this goes, okay. So now here's the question. How long will it take for the object to reach the desired height? Well, what's the desired height? The ground. Okay? I want to know, when is h going to equal 0? When is this going to equal 0? Okay, well, how would I do that? Because I can see both on my little picture here and this one here that I need to figure out, when does it cross the x-axis? What is the x-intercept? So here's how we're going to do this. This one is very much going to be easier for the time being using the technology. Okay? So here's what we're going to do. We got our handy-dandy help sheet. Again, right in with the lesson on the classroom if you don't have a packet. If you have a packet, this is within your packet here that you picked up. So we've already got the equation in. Okay, equation's in. We're going to do second. Let me get my face out of the way again. There we go. Second, trace. And we want number 2. We want to find a 0. The 0 is the same thing as an x-intercept when it's crossing the axis. Okay? So when I hit enter, you're going to see a little cursor. Okay, it's floating around way up here. And when we're done with this one, we're going to get the window back to normal because it doesn't need to be this huge all the time. And so only using your left and right buttons, okay? Only left and right buttons. Don't use up or down or things get messed up. I know from experience. So I'm going to start working my way down. And I want to get as close to the x-intercept as I can. Now, I'm not going to be able to get right on it. Well, that's pretty darn close, though. Oh. Okay, once I get close as I can, and it doesn't have to be perfect, just keep following the directions. 3 left arrow clicks. 1, 2, 3. And we're hitting enter. And now what I'm doing is, it's very faint, but you can see this little dotted line in this arrow. It's kind of like we're setting a border saying, okay, we're only going to check for the answer in this area. So that's my left border. Then 6 right arrow clicks. Do not freak out when the cursor disappears. It's okay. 1, 2, 3, 4, by cursor, 5, 6. Hit enter. Notice there's another line up here now with another arrow. They're pointing in at each other like, okay, right here, we're showing everybody this is where my answer is going to be because I'm looking for my answer right here. So one last time for x equals, we got to hit enter. We hit enter, and when it says 0, that's the answer. My height is 0. Okay, we said y is height. So my height is 0. My time when that occurs is 2.74 seconds. Which again, if I'm looking at my graph, also makes sense because notice where the cursor is at, even here, it's between 2 and 3, but it's closer to 3. So even guesstimating would get me pretty close if I had something to be doing with that. But again, keep this available. If you have your packet, use the packet. Okay? If you don't, pop it open on your screen. If you can print it, that's great, but otherwise, maybe you're going to have to put it up on your screen and then screenshot it with your phone to have it there. I don't know, but have this available. It helps out, and you'll get to know it as you do a few. All right. What happens, though, if we're working on this stuff and we are not in America anymore? We have to be able to adjust. That's it. So we're playing basketball in the Euro League. So again, metric, okay, the negative 4.9t squared. You release the ball at a height of 1.9 meters, an initial velocity of 8.1 meters per second. How many seconds till it reaches the rim, which is 3.05 meters high? Okay, lots of things that are in play here. So, first thing, let's label our pieces of what this is going to be. So, here's my initial, okay, negative 4.9 t squared plus, remember, what's in the middle? Your initial velocity. So initial velocity of 8.1 meters per second. Make sure I get the point in there. That makes a big difference. And you release the ball. Okay, so this is my h sub o at 1.9 meters. So I'm taking the j. It's up there a ways. And I get it up there. So now my goal at the end is to figure out when this reaches 3.05. That's the question. Okay? So if we want to be really super mathematical here, we would be like S of 3.05. If you just put H, I'm not going to tell you that's wrong. Okay? I'm just trying to have you aware of what things can look like when they look a little bit different. So, what's the deal? Okay, we get out the calculator. We're going to type this in. Again, negative, minus. We're using negative for this. It does make a difference. Try and stay out of the glare. We use an X instead of T. And before I hit enter on this in a minute, I want to make sure, because lots of decimals, make sure I've got, okay. So again, take a look at the graph. Oh yeah, I told you we were going to change this back, and we didn't. Okay, we definitely need to now. We're going to mess with the window here. Actually, this is even simpler. If you hit zoom, come up here, zoom. Okay. Zoom standard gets you back to the regular size. So, zoom standard gets us back to a 10 by 10 graph. Okay, and we can kind of adjust as we go. So here's the deal here. The only part I care about, again, is what's going on from this y-axis on over. So you notice these sketches, okay, now this one starts at my hand, it goes up a little ways, and then it comes back down. So what am I trying to find out? Okay, I want to know when it reaches the rim, okay? I want to know when it's 3 point, and I just realized I did a boo-boo. See, again, this happens. We're not saying after 3.05 seconds, that's what that would mean. That needs to stay as H. That is totally on me. So, how am I going to do this? Okay, couple of options. Here's what I would suggest. So here, we want to know the height at the end is 3.05. Okay, not in with the S like that before. Now, again, hearty suggestion, and this is from experience, this is going to be easier to figure out. Oh my gosh, why is my screen going crazy again? Hang tight here, just, hey, we're back in business here. My apologies again. Technology can be fun at times. Okay, so here we go. We were chatting about how am I going to figure out how many seconds until it reaches the hoop, because here's what I'm going to let you in on a secret. This graph, the vertex here by maximum at the top is not 3.05, okay? So here's what we're going to do. For Y2, we're going to type in the height that we're desiring. Okay, just, oops, 3.05, Hardy. Okay, so whatever the height you're looking for is what we're going to put into Y2. So this is in my first one. This is in my second. Now watch what happens. This line is going to go through. You're like, it's going through in two places. But when I'm shooting, I'm curious on when it's going to get there the first time. Not hoping for the bounce here. I'm hoping it just goes swish and goes in. So I want to know what that intersect point is. Okay? So we're going to teach you one more trick on the calculator here. So for an intersection, which we have in a case like this, again, just kind of getting you used to some of the things as we go, we are going to hit second trace. If you want, you could even add this to your apps if you wanted to. Second trace, and we want number 5, which is intersect. Okay, so your little cursor is going to show up. You don't have to do anything, okay? All we're going to do is hit enter 3 times. We're going to hit it once that it's on the parabola. Then the second time it moves to the red line, which is our second curve, which is that straight horizontal line. And then the third time of hitting enter is for the guess. And again, X is your time, okay? So your time is 0.16 seconds. Pretty quick, but when you think about when you're shooting basketballs and stuff, it doesn't take long for something to get there. We must have been pretty close to the rim. Okay? That's your easiest way to go. There will be some more ways as we move ahead with using like the quadratic formula and some of those things that would work, but for our purposes, we want to keep life simple. So that's going to be the easiest way to go. We also can get a few bits of help in dealing with other functions as well, like something like this with a rectangle. The area of the rectangle shown is 105 square meters. Find the value of x in the dimensions of the rectangle. Okay, how do we find the area of a rectangle? Let's rewind to that first. Hopefully you said length times width or base times height. If you said that, that'd be okay. So we'll call this is our length and this is our width. So here's what that would look like. So area equals length times width or width times length, okay? For me to be able to figure this out, I want to get this into standard form of a parabola, of a quadratic. So I'm going to distribute my x. X times 2x isn't 3x, it's 2x squared. Remember our exponent rules. We're going to add the exponents. Plus 1x. But I need it in standard form. Everything is on the x squared side. So that 105, I want to move over here. And we're going to do that. Okay, so you're like, okay, now where has this gotten me? This doesn't look any easier than it was before. What do you want me to do? Okay, we're going to pull out our handy dandy calculator. We're going to get some assistance here. So we're going to go back to y equals. We're going to clear everything else out. We don't need the 3.05 to help us anymore. Oops, not 15 though, 105. Okay, let's see. We may have to change the graph around here a bit. Okay, so here's the deal. We're trying to find an x value of this rectangle, okay? Now, the x value that we want is going to be one of the x-intercepts. Now, I see 2 of them here, but here's the question. Do I need to know what both of them are? And the answer is no. Because can the side of a rectangle be a negative number? Because these are all negatives as I go over to the left. No, so I don't care about this one. This is the only one I care about. Okay, so there's a couple of ways that I might be able to figure this out. One is going back to my handy dandy help sheet. And I already did the y equals. So I could do second trace. And number 2, I'm looking for a 0. Okay, now you're like, Hardy, I don't see the little cursor dude anywhere. Well, it might be a dudette, I'm not sure. So here's, when in doubt, okay, start arrowing to the right. And here's what I want you to notice. Notice how the x value is getting bigger, and now here I just crossed 1. So my cursor guy is somewhere way down here. Whoa, negative 101. About where 1 is. So keep watching x as we keep hitting the right arrow. Now we're at 2. Now we're at 3. Now we're at 4. And notice the y value keeps getting closer to 0. So we're almost there. 5. 6. Okay, we should be coming back into the screen. There's our cursor. Okay, as close as we can get to the x-axis. So that's about as close as we're getting this time. Left. 1, 2, 3. Enter. Again, don't worry if it disappears. Right. 1, 2, 3, 4, 5, 6. And enter. Again, just because it's off the screen is not a bad thing. And one last time for our guess. And it says x equals 7. Now, one tricky thing that I want to mention before we put our answer down. Sometimes, if it looks like your intercept is going through at a whole number, if you pull the chart and you see a 0 in the y column, that's your x-intercept, okay? So if you see y equals 0, that equals an x-intercept. Now, our question, we're not done because it says what are the dimensions of the rectangle? I got to plug this back in. So plug in 7 for x. Plug in 7 here. Whoops, probably helped you could see what I was pointing at. Plug in 7 here for x. And if I plug in 7 here, 2 times 7 plus 1 is 14 plus 1 or 15. And last I checked, 7 times 15 is 105. Now again, this is challenging. Keep the help sheet near, or if you took a picture with your phone, keep that near. But otherwise, as you start doing the practice, again, keep all your notes right there so you know, oh yeah, initial velocity is that middle number. Oh yeah, the initial height's that number at the end, so you can start working. We might have to pop a video on a couple of these sometime to look at some things, but try them out. Do everything that you can, okay? You got this. I'm confident in what you got here. Let's do it.